Another group of parameters, point group. What is a point group? A point group is essentially the object you're tracking. We load a camera, assign it the appropriate lens, and begin tracking motion. The thing we're actually tracking, that's the point group. You load the shot, configure the camera parameters, and then track points within a point group. These groups are logically separated by the objects you're tracking. By default, the first thing we track is the camera. A default point group is automatically created in the scene, and all points you start tracking belong to this group, which means these points are used to track the camera motion. But what if you want to track more than just the camera? If you want to track multiple objects in a single shot, first you track the camera in the initial point group, then you create a new point group and track the next object inside it. If there are many objects, you create multiple groups, one for each tracked object. This way, your tracked points stay organized and properly linked to the correct motion, whether it's the camera, an actor, a car, or any other moving element in the scene. We can also switch between created point groups by double-clicking on them. By default, one point group is always created automatically. Let's go over its main properties. Groups can be toggled on and off. This is especially useful if you're tracking not just the camera, but multiple moving objects in the shot. For example, if one of the tracked objects is getting in the way of the camera solve, you can temporarily disable its group and come back to it later once you've got more reliable data. It's best to name your point groups clearly, especially when working with multiple ones. Let's say you have a group called camera for tracking camera movement, another called car for tracking a moving vehicle, and actor for a tracked character or person. This is the logic behind grouping. Every point group should correspond to a single object, whether it's the camera or any moving element in the frame. For example, if we have a moving camera, we track it relative to static objects in the scene, like the road surface. So all the points that lie on the ground should belong to the camera group, since that group tracks the camera's movement relative to a fixed world. So, for example, when tracking the camera, you cannot use points placed on the car because the car is moving, and that will create false parallax. The same applies to a person if they're in motion. You should only track the camera using static elements in the shot. In this case, that could include the asphalt, curbs, buildings, or even a person standing completely still. If you want to track the car, you must create a separate point group and track only the car using trackers that are specifically attached to that object. No other elements should be added to that group. Likewise, if you're tracking a person, their point group must contain only trackers placed on that person and nothing else. This is how you separate camera tracking from object tracking. Then you give each point group a name, camera, car, actor, and set its type. Camera, if it's used to solve the camera motion. Object, if it's tracking a moving object relative to an already solved camera. You must always track the camera first. Only then can you track objects relative to that solved camera. If you accidentally create a new group and set it to camera, while the previous one was also camera, 3DE will automatically change the old one to object. Next, automatic root frame detection. In PFTrack, this is called initial frames, and in other programs it may be named differently. What are root frames? Root frames are the key frames between which the camera motion is confident and easy to track. In most cases, the software will automatically determine this range, and usually you don't need to worry about it. However, there are situations where it's better to manually define a more reliable section, especially if you know that. That section has the most solid trackers, the camera moves smoothly and steadily, there's no motion blur, smoke, bright lights, flares, or other interference. By default, 3DE handles this fine, but if the automatic choice doesn't work well, you can manually override it. When should you define root frames manually? Well, I often explain this using smoke or fire as examples, but those aren't the only obstacles to good tracking. Any section that contains lots of moving objects, lens flares, or light overexposures, poor quality trackers can turn out to be a bad choice for root frames, and in those cases, it's best to manually set a clean segment. Here we see the camera moving smoothly, but then suddenly a person flies across the foreground and they block our view of the background elements. So in this case, the root frames should be set just before the person enters the shot, because in that segment, the camera motion is clean, readable, and easily interpolated. After that, we're essentially telling the software, or rather, it figures this out on its own, that it should interpolate the movement, because part of the data gets occluded due to the person blocking the frame. Still, the main motion of the camera is assumed to continue, but it's just not well tracked in that segment. That's the idea behind root frames. Next, post-filter. Footage often contains a lot of noise or jitter, and the tracking may not be 100% stable. These small inaccuracies can lead to microshakes in the solved camera, especially visible on distant background objects or in compositing. The post filter is a smoothing filter. It applies a soft pass to the camera or object motion calculated within a given point group. In short, it smooths out the tracked motion curve. It preserves the shape and geometry of the motion. It just makes the solve visually cleaner and less jittery. You can either disable smoothing altogether or choose between two algorithms. standard smoothing, or Fourier-based smoothing. The position parameter controls how strongly the smoothing is applied. Throughout my entire career as a match mover, I can count on both hands how many times I actually had to disable smoothing. Those were usually very specific cases when the footage was absolutely clean, and it was crucial to preserve tiny micro movements of the camera, like handheld jitter, micro vibrations, etc. By default, the software treats those tiny jitters as errors and smooths them out. So if you really have a perfect track and you want to preserve every subtle nuance, you can disable smoothing and the solve will land perfectly in comp. But in most cases, don't hesitate to keep it enabled. It works very well and your solve will be more stable. Just keep in mind where to turn it off. If your solve suddenly doesn't match the backplate, check the smoothing settings first. The invert point cloud parameter. What does it mean? After tracking, you get a 3D layout of tracked points. The software distributes them some closer, some further away, based on the depth of the scene. But when there's not enough information, like if there are too few trackers or they're spread unevenly, the software can make mistakes. It may misinterpret the depth, for example. It might think objects that are actually near are in the far background and move background objects closer to the camera. Visually, it looks like the scene is turned inside out. Everything feels like it's popping out in reverse. That's what we call an inverted point cloud. The first thing to do in that case is to add more trackers, especially on intermediate depth planes between the foreground and background objects. And in most cases, that's enough to fix it. The point cloud will recalculate correctly. But if you're working on a shot where you can't add any more trackers and you end up with an inverted point cloud when viewing the scene in 3D space, you clearly see where the cameras are, and it's obvious that nearby objects are appearing far away. You can fix this using the invert point cloud option in the point group settings. You enable the option, select one point that should be closer to the camera and another that should be farther away, then run the calculation again. That's how it works. Next is the motion capture section, but it won't be covered in this course. That wraps it up. These are very important parameters. You need to understand how they work, what they affect, and when to use each of them. These are all the parameters related to the point group. Of course, we'll still deal with settings moving forward, but starting next lesson, we'll jump into tracking.